Today we're going to be talking about BGA stacking. And we're going to start with what is BGA stacking. BGA stacking is when you literally stack one BGA on top of the other. Now, this second or the bottom BGA is usually an interposer, substrate, a reducer, an expander. Different companies call different things, but that's when you have a ball grid array on the top assembled onto another ball grid array, and then this package is assembled onto the PCB. Now, usually what we do is you have the top one assembled onto the bottom one, and then this whole package assembled onto the PCB. Why would you do that? Because that increases the complexity of the assembly by quite a bit. Why would you do that? There are a few reasons. You can have design changes, right? If you have been using one type of BGA and you decide that because of a mistake or because of changing the requirements of your product, you have to go with a different type of BGA, you can use this new BGA with the same footprint as the old one, thus do not require you to redesign the PCB, which can be very costly. You have two options. Either you redesign the whole PCB or you just design an interposer that will be able to mate this new BGA to the old footprint you had. Another reason is obsolescence, right? So if the component becomes obsolete, now we have to go with an equivalent or an analog component that very likely will have a different footprint. So you design an interposer to interface that new BGA with the old pinout that you have. Again, you have the option to redesign the whole board, but that's usually quite expensive. Lastly, and this is one of the reasons that we saw a huge uptick in this technique in the past few years with the supply chain shortages due to COVID, is that all of a sudden that component you've been using, that you design your board to use, that doesn't exist anymore. You just can't find it. So you end up having to choose and pick something else that's available in the market, and something that might not have the same footprint as the old one that you've been using. For that reason, you have to design an interposer that's going to allow you to interface this new component to the old footprint you had. Same story, different reasons. They all create complexities in the assembly. And to show you how these complexities and how these issues are going to show up in an X-ray machine, we're going to use one of our test cards to exemplify how you can identify and how can you fix these issues on your assembly. So we're going to go downstairs now in our demo room, and we're going to X-ray the board and show exactly how these defects are going to present themselves. All right, now that we saw why and how BGAs are stacked, let's go check here in the X-ray machine exactly how that stacking looks like and how to identify the potential problems of BGA stacking. So, starting with the stack itself, you're going to see we have two different ball sizes, right? You have solder balls that are larger in diameter and solder balls that are smaller in diameter. So that's representing the BGA itself, the component, and the interposer. In this case, there are quite a few heading pillow and opens on this package, and I have some images here I want to share with you that so you can identify how they look like. On the straight down view, an open is going to look like this. You have the solder ball, right, which is the dark circular object, and if you don't have a connection, you're going to end up being able to see the pad itself like this. A clean pad shows that you have an open. There is no wetting between the solder onto the pad. We have then the ability to move the sensor at about 45 degrees to have that side view of the component. So this is a really nice one to show you. You have three different balls here in this roll. This one has some wetting, as you can see here. You know, there's a fillet of solder connecting the ball to the pad, and you can see that fillet right here. This one, there's nothing. You see the pad is right here, nice and clean. And the ball is also nice and clean. If you see a round ball in this tilted view, it's usually a bad sign because it means that the ball didn't collapse, which means that there was no wetting, either because of temperature was insufficient, the temperature in the reflow was too low, or the temperature was right and you just didn't leave there enough to properly soak and get that solder to melt and wet to the pad, or something happened on the pad, some surface was dirty or the surface finish wasn't proper, and as a result, even if the solder melted on the ball, it wasn't able to wet to the pad and make that nice, clean metallurgical connection that you want to see between the BGA and your board. So all these things play a role, or because the BGA was sitting too tall, right? And it's just, so the ball melted here, but it was too high because of coplanarity issues or potato chip or popcorn, right? So the BGA was too tall, and even if the solder was melted in liquid, it wasn't able to physically touch the pad, and as a result, you ended up with the solder ball melting, getting liquid, and like, oh, I'm not connecting to anything, and then solidifying again far away from the pad. So any of those reasons are diagnostic features. They have to go back and figure out where in your manufacturing process the mistake was made. But this is how you identify it on X-ray, and that's why if you're just taking X-ray images, you're collecting data. Data by itself is useless. Data that you don't use is noise. Data that you act on, that you use to identify processing issues in your manufacturing line is called information. Information is data you act on. And what we want to do is to have you using your X-ray machine as an information source. Information source that you can use to then diagnose your line and figure out exactly what's happening so you can fix it. And because problems you don't fix are costs, and costs reduce margins, right? So we want to make sure that you can use your X-ray machine to make money. And you do that by connecting an X-ray image like this to the source problem that can be a reflow oven profile. So hope you enjoyed this video. Please don't forget to subscribe and call us, email us, so that if any comments or any other videos you want to see. And again, thanks for watching.